Hello everyone, and welcome to Knowledge Discovery and Data Mining, the second webinar of a short course presented by Charles Sturt University. My name is Guy Coward and I'll be your MC. Your mentor is Zahid Islam. Before we begin, as usual, the housekeeping. We encourage questions and the use of chat during the webinar, and we ask that you direct all questions relevant to course content to the Q&A section particularly, and that you send all administration type questions to the support team in chat. So any sort of questions about dates or quizzes or resource availability, for example. You can also just chat with your fellow students, and you can choose to do that by setting your chat settings to all panelists and attendees using the Dropbox once you've opened the chat log. There are almost always very experienced industry-based attendees who'll be most helpful with any queries you have, and they'll be able to augment the content that we deliver tonight. On that content, we'll have a few videos tonight and a lot of Q&A if it comes up. And if a question is particularly relevant, I'll interrupt Zahid in the middle of a slide. Leif is, as ever, here in an administrative and technical support role for IT Masters. He's responsible for the course page at learn.itmasters.edu.au, which is where you'll find all the materials and webinar recordings. If you have any questions about the course page itself, please feel free to contact us using the details on that page. No guest lecturer tonight. We have a full hour of full salvo nerding out with Zahid, which I think is very nice. Can you please welcome Zahid and make him comfortable?
Thank you very much. Thanks for, again, a nice introduction, Guy. And I'm just double checking you can hear me, my voice coming through.
Yep, loud and clear. Sounds good.
Loud and clear, okay. And thank you very much to all participants for coming for the second lecture. I hope you will be enjoying this. And today we will talk about knowledge discovery a little bit more, use of decision trees and forests, how we can use decision trees and forests for knowledge discovery. And we will also see a couple of applications of data mining, some short videos, etc. And look, in this subject, we actually teach also some background information on how decision trees are built and etc. At least some basic idea, basic concept of the theoretical side. But in this lecture, I will try to avoid this because we want to give an overview and a good understanding of some subject materials, etc. Okay, so I don't think I need to introduce myself a lot again, but you know that I have a colleague who will be giving the lectures from next week. So next week and the following week. And he is Dr. Michael Byong. I introduced him last time. He's a wonderful data miner, and he will be discussing knowledge discovery, decision forests, data, whatever, what is that? Decision support system, and he will introduce those topics. Now, as you know, my name is Zahid, and we also have a data science research unit here at Charles Sturt University. And that data science research unit, our colleagues are working in various research areas. And that data science research unit has 5 different groups: Advanced Networking Research Lab, Data Mining Research Area, Imaging and Sensing Research Group, Cybersecurity Research Group, and eHealth Research Group. So our colleagues are working on various research topics. And we are actually part of, I think, around $150 million cybersecurity CRC, where there are about 7 or 8 universities collaborating each other with many industry partners and with government funding. And our university is also part of Food Agility CRC with a similar amount of funding for 10 years, and then also Soil CRC. So what I want to say is that this group of researchers are actually actively working on various research topics, various research projects, and that generally helps them to convert their experience and knowledge into teaching as well. So it is a very, very nice achievement that we have a nice data science research unit, and in terms of computer science and information technology research-wise, we are ranked at world standard by Australian Research Council, ARC, and in some parts, some subdivisions within the computer science and information technology, we are ranked above world standard. So overall, we are at world standard, but in some of them, we are above world standard. So it's a very active research group. And so the information, for example, personally, I work on, along with my other colleagues, of course, I work on various industry projects, and that knowledge and experience I find it useful in teaching as well. Okay. Now, the next slide is a small introduction about our school here, School of Computer Science and School of Computing and Mathematics, we call it. And according to university reviews, here is the web link, we were ranked third. We were ranked number 3 in terms of best computer science universities in Australia. So as a computer science school, we were ranked number 3. And that ranking was actually based on number of students, student satisfaction, the grad salary of our students, and that these 3 factors contributed towards a pointing system, scoring system, and we are in that sense, we are ranked number 3. So it is, look, this ranking is not very important, but what we are trying to understand from this, that possibly we have good number of students, and our students are reasonably happy with us. We take it very seriously, and we adjust our teaching, our course materials, etc. Accordingly. We try to understand the student needs, and also in order to provide better education, better service, etc. And also one information I have that is in 2017, in terms of the headcount enrollment, our school had 6,025 or so enrollments, which is the highest in Australia. So in terms of number of enrollments, headcount enrollments. Okay, so we are, in that sense, we are the largest IT education provider in Australia. So now this course, the Graduate Certificate in Applied Data Science, this course has many subjects, one core subject and many optional subjects, elective subjects. So the subject materials that I am delivering through these lectures is only from one of those subjects, ITC 573, Data and Knowledge Engineering. But this is an elective subject, so you can choose this subject or you may not choose this subject. If you are wanting to study graduate certificate in applied data science, then it's up to you whether you choose this subject or not. But the way we design the subjects is aiming to cater for different groups of students and their needs, so that some students may want to learn more statistics and statistical techniques, etc. So there are statistical subjects there as well, scientific statistics, STF 501. Some students may need to learn a little bit more about database structures, schema design, ERD, entity relationship diagrams, and those kind of things. So there are various different options for this subject, for this course. Okay, now coming to our lecture today, and that's a brief introduction to the school, to our data science research unit, and the course. Now coming to our lecture today. Last week, if you remember, we were talking about the data lifecycle, and we introduced what is data collection, very briefly, of course, and then we also briefly introduced how to do data pre-processing. Remember, we were showing missing values and how to impute missing values, and we also discussed the corrupt data how data can get corrupt and etc. And there are techniques for automatic detection of corrupt data as well. And also we discussed briefly discretization, scaling, etc. So these are pre-processing. And then we discussed briefly about data analysis, how to now analyze the collected data. And we were showing you very briefly a decision tree. We used Weka. Look, Weka is just one software tool. You can use any other software tools for data analysis, commonly used software tools. Weka is one of the most commonly used software tool for research and education purpose, because there are lots of freely available software packages or software algorithms programs there in Weka already. So generally researchers use this, but there are many other more commercial version of programming or data mining tools. Other commonly used tools could be Orange is another one where you can actually use various data mining tasks, or you can apply various data mining tasks there. So that sort of thing. So we are using Weka here because it's easy to demonstrate things, and it's good to understand how data mining works in real life. And we have some algorithms there as well. So today I will show you a little bit more about what is a decision tree and what is a decision forest. Remember last week we discussed that there is a thing called decision forest, which is an ensemble of trees. You can build more than one trees, and how those things can help you to discover knowledge. So that knowledge discovery thing, and also a little bit of idea about how this knowledge can be conveyed, published, or kind of shared with non-data science people as well. So we'll discuss those things. And last week we also briefly discussed about some industry projects, just to see as an example of the possible use of data mining and knowledge discovery in various real life projects. So look, this is not a complete list, it's just an idea. One of my students who was studying one of these subjects, he told me that he actually works in a high school as a high school teacher, and with this subject now he can now actually analyze his students and the reasons why some students are performing well and some students are not, because he has information about lots of students, and many of them were performing well, many of them somehow were struggling. So now he can actually dig out more information, more knowledge from those type of data. So this kind of thing you can do in your workplace as well, if you are not already using data mining. After this course, after this subject, couple of lectures, possibly now you know how to do this, and you will know a little bit more. But I understand many of you are quite experienced in data mining and you are using it already. So like these industry projects are like health monitoring system that we developed for patient welfare and better hospital management. The Colimbli irrigation project was for irrigation, water demand prediction, etc., and so on and so forth. So we discussed those projects last week. Now today I will actually show you a quick video on another possible application of data mining, and we published a paper on that in AusDM, Australasian Data Mining Conference in 2016, where we actually developed a decision support system that collects information from various sources like Bureau of Meteorology, New South Wales Water, and Weather Zone, and then it combines the information, processes the information, and displays the information in a decision support system for better understanding of the data. And a user, for example, a water manager or a dam manager, this particular paper was using dam management as an example, water dam management as an example, and a manager can actually try to understand the weather condition, the water flow, etc., and also then he can build models like the decision trees and decision forests that you saw a little bit last week, and then use those forests and decision trees in order to predict future. So he can predict, and he can actually choose various target attributes like dam water level or dam inflow level or etc. And dam outflow and many other things. So he can choose target variables as he needs, and then he can actually develop models and he can predict them in advance. Okay, so this sort of thing, and here is a small video for that, and I hope this is only 1.5 minute long video.
Hi, my name's Michael. I'll be walking you through CSU's new Water DM.
So this is only 1.5 minute long video, and I hope this will briefly explain what is a decision support system and how data mining can be used in that in a decision support system. Okay, let us run it.
Hi, my name's Michael. I'll be walking you through CSU's new Water DM system, a web-based decision support system powered by data mining. What is Water DM? Water DM allows everyday users to experience the power of data mining by selecting some simple parameters and clicking a button. The user can then explore the data mining model using a powerful new visualization system that provides statistics and useful information on the fly. For time series data, the user can graph data points over time and compare variables, as well as check the accuracy of a particular model over the data collection period. The system can be used to predict either numerical or categorical class values, which are displayed on the prediction page. The system shown here has been used to predict a variety of variables relating to Burrendong Dam in the central west of New South Wales. Every day, the system fetches weather predictions from the Bureau of Meteorology, Weather Zone, and past data from the New South Wales Water real-time data site. The flexibility of the system allows us to customize it to use any dataset the user require. We can also add any additional functionality due to our system's modular design. If you're interested in more information, email Dr. Zahid Islam at zislam@csu.edu.au. Thanks for watching.
Okay, so that that was an example how data mining, data analytics can be used for water management. If you are interested, you can have a quick look at that paper that I showed in the previous slide, and you know how to find them on my webpage, right? So you can Google search me, go to my webpage, and go to the publication page and search for that paper. You can Control F and search. I showed how to do it last week, so I'm not I think that's nobody needs that again. Okay, another example of use of data mining could be smartphones. So data mining on smartphones. So these smartphones today that we use, they are very powerful. And for example, most of the smartphones are not the high-end, costly smartphones, like reasonable priced, medium and lower-end smartphones. And can have 8-core processor, 4 gig RAM, etc. So they are quite powerful. So we were thinking that whether we could do data mining, complete data mining on smartphones. And at that time, we did not see any smartphone data mining app like you are using Weka here on desktop machines or laptop machines, PCs, for data mining, and you can actually choose various algorithms for classification, for clustering, for data pre-processing, etc. But for smartphones, we did not see any app like that. So we developed an app called Data Learner that mimics actually Weka, but for Android phones. And so that, and then we also studied the impact of that, how the speed of the phones compared to PCs, and then also temperature, user experience in terms of complexity of running the data mining algorithms, accuracy, of course, and all these things. And we found it actually very encouraging. It's doable, and the app called Data Learner is freely available. Is freely available for downloading from Google Play. Just search for Data Learner, and also the source code is also freely available from GitHub. Here is the link for that. So we have implemented around 40 different algorithms there in Data Learner. So you can choose an algorithm. You can upload your data set in the in Data Learner app, and then you can actually choose an algorithm and just run it to discover knowledge, to get the models, etc. So that is doable, and I'm now showing you a small, again, less than 1.5-minute video to introduce that Data Learner very briefly. But again, we have a paper on that. You can search for that paper on my webpage, and the preprint of the paper is freely downloadable. You can read that. Okay, let's see. Here is the video. Okay, I'm running it again. Okay, so this video introduces that app, and you can actually download that app from Google Play and play with that on your smartphone. Now, you may be thinking, like, why we need to do data mining on smartphone when we have powerful desktops and laptops? Why and how much we can actually do on smartphone? So there are quite a few advantages, possibly. Yes, there are disadvantages as well. It will not be as convenient as a laptop, as a small screen. You can do limited, like applications there. For example, you can't open Access, maybe there, Microsoft Access for making more queries, or you cannot use Excel, that sort of thing. But the advantages are also there. For example, it gives you more flexibility. You can do your data mining at some time when you are not on your desk, at your desk, and you are not using your laptop. On top of that, these smartphones, this data mining on smartphone actually does not require your data set to be sent to the central server. You can actually do the data mining on the phone, and your data set is not needing to be, you don't require to release your data set to somebody else, that sort of thing. And an obvious application of that is if you are collecting data related to you using your phone and then want to mine that. And the following slide will possibly show you an example of that, an application of smartphone data mining. We published this paper recently in possibly OSDM 2019 this year. That conference is going to happen in Adelaide from, I guess, 2nd of December to 6th of December. And in that paper, we showed the readiness of smartphones for data collection and data mining with an example application in mental health. So what it does, so these smartphones, they actually have lots of sensors, many sensors, quite a few sensors. For example, they can sense the light, how bright or how dark it is, and depending on that, actually it dims down or it brightens up, your screen, so it can sense light. So if someone is living in dark for a long time, it can actually sense what is the light, if it isn't very bright or not. It can also, it has accelerometer, so it can also sense movement. So if someone is moving or not, if he's carrying the phone and sitting somewhere, it can sense that. It can also sense proximity. For example, when you bring your phone close to your ear, then and possibly when you are talking, although you are touching the screen, the screen is inactive at that time. It does not change the apps, or it doesn't drop the connection. So it has the proximity things, and it can also store information about, say, your web browsing, or your your messaging, how much message you are sending, or how long you are talking, how many calls, etc. So it has a lot of sensors. So what we did in this paper, we used the sensors to collect information about an individual, the individual who is using the phone. And then after that, okay, these are the sensors that we used: accelerometer, screen activity, proximity, phone call log, SMS log, etc., light sensor, which I explained before, etc. And then we said that we created a app. We developed an app called Mindful, and that can actually collect information using the sensors about an user, and then it can create a data set. Every day it keeps on collecting the information, and then gradually it builds a data set. And also every day we ask a question. So this is how the interface of that app looks like. So every day a user will need to answer these PHQ-9 questions, which can assess his or her mental health condition, feeling depressed or not, that sort of thing. So what we are essentially doing, we are collecting all different sort of user activities, movement and all these things, and we are also collecting information about these PHQ-9 questions to determine his or her mental health condition, and then we relate the other activities with mental health condition. And after we collect this data for, say, a few days, maybe a month, 2 months, 3 months, we have a reasonable size data set that can actually, then the smartphone app will also have a data mining capability that our algorithms are installed there. So then it mines the data set and understands the relation between different user activities with their mental health condition. And then it tries to predict in future. So after a couple of months, even if you or the user does not, that's the idea, even if a user does not record or does not answer these survey questions, PHQ-9 survey questions, the app can still identify their mental health condition, because it has learned that relationship from the previous collected data, their user activities and mental health condition. So in future, just watching the user activities, they can predict mental health condition of that particular user. Now, mental health condition can vary in terms of the relationship between user activities and mental health condition can vary. For example, can vary from person to person. Sorry. For example, if a doctor works in a hospital at night, then at night he is not sleeping, he is moving around. Or a security officer working at night, so at night he is not sleeping, he is moving around, he turned on his light, he's in a lighted area. So those kind of thing does not reflect his or her mental health condition being poor. Whereas for many other people who are supposed to sleep at night, they are not sleeping at night, may mean their mental health condition is not so good, they are struggling. So it is the relationship between various activities and mental health condition can actually vary from person to person. So therefore, this app, because it is individualized for an individual user, and it only learns from that user data, can be very applicable for that user only. So we then tested this with a synthetic data set, and we found that it can be very useful. Look, the reason we are not releasing this app, because that requires serious ethics approval. And the dataset we used is not real life, it's a synthetic dataset. So we cannot guarantee that this will be useful or this can really identify mental health condition. But we find it really very interesting to see that mobile phones, smartphones are ready, technology-wise, they are ready for doing these things. They can be used for things like this. So that's another example of data mining application in real life, right? Okay. So after that, now we are deep into today's lecture, maybe. We are now showing how decision trees and decision forests can be used for knowledge discovery. Okay, so in this case, last week I was showing you a very small toy example dataset, but in this case I will be showing you a real life dataset called diabetes dataset. And using that diabetes dataset, I will demonstrate how you can discover some knowledge, what generally people in real life use, how they work in order to discover knowledge. We did a couple of a few industry projects on knowledge discovery, to discover information, to discover knowledge and report that. So we used similar sort of approaches there as well in those real life projects. So I will demonstrate that now. And I possibly have a video here again. And this is a very recent video. I was basically doing it for this lecture purpose. And I have uploaded this video on YouTube as well. I will share this. I will show this video now, run this video now. It's a little longer than the previous two videos. It's 15 minutes. But the reason I'm showing this through the video is because then it will be very systematic, because this was captured carefully. And then I will show you some screen sharing from here to show you a little bit more about this. So this video is basically introducing how you can use decision trees and forests for some knowledge discovery. Let's enjoy. Okay. Welcome everyone to Zahid's Data Mining channel once again. My name is Zahid Islam, and today I will be discussing knowledge discovery and data mining. And we will also talk about how we can actually discover knowledge, and I will demonstrate a real knowledge discovery from a real data set. Okay. Now, we published this paper called Forex++, a new framework for knowledge discovery and decision forest. And in this paper, we discussed some initial ideas of how to discover knowledge from a data set, what is knowledge discovery, and how to also present the knowledge in an interesting way to some extent in this paper. And in a following paper, we then took this to further details or further improvement. I will discuss that also very briefly. So to demonstrate this knowledge discovery, in this video, I have just downloaded a freely available dataset called diabetes.arff dataset. Diabetes dataset. .arff is the format for WECA, as you all know, and you can see it. These things, you can learn these things a little bit more from my other videos if you like. So in this dataset, there are about 9 attributes, 9 variables, and one of them is a class attribute, which is diabetics test result, whether it is tested positive or tested negative. So this is the data set you can see, and these are the variables like preg means pregnancy, how many times the patient was pregnant, then plus, press, skin, insulation related information, etc., age, and then finally class. Now I have opened this data set in WECA. This is, you can see WECA Explorer, and here you can, through this open file, you can open any dataset. Here I have diabetes.arff, and we can open that dataset. And now you can see various variables. Now for knowledge discovery, this information can also be useful, that you can actually see the distribution of different variables, how many people, what is the minimum, what is the maximum, etc. And if you go to class, you can see there are 500 tested negative people and 268 tested positive people in this dataset. But often people will build decision trees and forests to discover knowledge as well. So here we can choose a decision tree algorithm. Say, for example, in this case, I'm choosing J48, and we can actually build a decision tree, and this is how the tree will look like. That will give us lots of information. I can choose some tree parameter to make the tree a little bit more sensible. For example, I'm saying choose at least 50 records in a leaf so that my records are more like sensible, and then from that I can discover some knowledge. People will also use decision forest instead of a tree, where they can have multiple trees to discover more knowledge. Okay, so let me show you an example, and then I will explain them of a decision forest. Say I'm using sys4, that's our own algorithm that we built, that we proposed a few years ago, and then we can possibly choose some minimum number of records, etc. information, so that we can build some sensible trees. So here we can choose some parameters for sys4. Say, for example, we are choosing 50 records in each leaf, so that every rule that it discovers contains at least 50 patients in it, so that the rules are more kind of reliable. It's not based on 2 patients, and that can be a pure coincidence. So 50 patients there, and the number of trees you can choose a suitable number of trees. The more trees you choose, generally you are trying to discover more knowledge. So 50 by default it creates 60 trees. So now when you build it forests like that, then you can see there are 60 trees, tree number 60 there. But the problem is it can be huge. That's one problem people are suffering from, and that is huge number of trees and lots of rules, so lots of knowledge, and then it becomes difficult to discover which knowledge, which rule sets are more important, more useful. For example, a little bit of interpretation of this is, it says that if class value is less than 166.5 and then mass value is less than 26.3, then these patients are tested positive. They are diabetes from this dataset, and there are 159 such records that have class less than 166.5 and mass less than 26.3, and only 9 of them are positive. So 150 of them are negative. So it's a predominantly negative people in terms of diabetes test. Now the paper that I was discussing actually presents some interesting idea that how do you now discover more interesting knowledge. So it says that you first find out the rule sets that have accuracy above the average rule sets accuracy, and then that has coverage also above the average coverage, and the lengths are also short, that lengths are smaller than the average length of a rule. So smaller rules are more understandable, interpretable, something like that. So to understand the proposal in the paper, let us build a small forest of three trees. Number of trees will be 3, and then so that we can demonstrate this. And now we can see that these are the trees, tree 1, tree 2, tree 3. So following the suggestion in that paper, we first write the rules on an Excel file as follows. So here is the Excel file, you can see, and that's tree 1, rule 1. So the first rule is class less than 166.5 and mass is less than 26.3, you can see here. And then we are saying it is negative. There are 159 total records, only 9 of them are positive, so 150 of them are negative. And then we can calculate the support. Support means how many records fall in this group, so that's 159, and confidence is what is the accuracy level, confidence level. So it's 150 over 159, which is 94.3. So this way we can write down all the rules. Okay, so that's the reason why from 60 trees, for demonstration purpose, I said that we better choose 3 trees, so we can write all these rules. Now in real life you will have a lot more, and then the support and confidence. So as a result of this, you can actually then rank the rules in terms of their confidence and support or whatever. So here now I can see that true tree 2, rule number 7, that gives the highest confidence, so that's the 94%. Now if you are interested in only positive rules, so you are interested in those people who have diabetics, then you can see this rule which says if plus is greater than 166.5 gives the highest confidence for the rules that identify or that predict positive diabetes positive patients. So here 86% accuracy. Now this is how you can actually discover and you can play with interesting rules, and you can find out rules. So you can possibly find out top 10 rules in terms of support, in terms of confidence, or in terms of lift, and you can choose many other criteria. Now you can also, after you identify some interesting rules, you can also explore surrounding those rules to see what are the information there. So to explore the other side of the rules, or when you identify some rules, you can then decision trees and forests can help you to identify interesting rules like this, and this you could find without any pre-assumption, any domain expertise in that sense. So this knowledge, these rules are coming out automatically from decision forest, and then you can identify that maybe this is one interesting rules because it says plus greater than 166.5 means positive. Now what is if it is less than 166.5? What is not 166, 150? So can I discover knowledge? And then for doing that, here I have opened the file, the dataset in Microsoft Access, and let us write some query to see what is the class distribution when the class plus value is actually not greater than, rather less than 166.5. So I'm writing some basic SQL query here. Diabetes dot plus is actually less than equal to 166.5 instead of greater than, because that rule says greater than. So I'm now checking if this is less than, what happens. Dot class equals tested negative. So I'm trying to see like how many records are actually tested negative and how many records are tested positive when plus value is less than 166.5, whereas this rule says plus value is greater than 166.5. So once I now complete this this query and run this query, I can see that there are 489 records with negative class values, and similarly I can run this query again to see how many of them are positive, and then I can see there are only 200 positives. So from this I can see a class distribution when it's actually different, the plus value is different, and then from that I can write an Excel file like this with the new class distribution. So when case 1, then this is the percentage of positive and negative. Case 1 means this rule, and case 2 is this other query, and I can see the distribution difference. So when plus is greater than 166.5, then there is a huge number of positive compared to negative, whereas when plus is less than 166.5, then there is a very big number of negative compared to positive. So I can actually discover this sort of knowledge from this. So this is and this is a simple demonstration. You need to do it more and more to actually learn more about the data set. Data mining and knowledge discovery is mostly about making sense of data. So you can actually keep exploring these things and learn more and more knowledge. So as a demonstration of knowledge discovery, we in this paper, Forex++ paper, we actually demonstrated and applied this approach on some real-life data sets. For example, this was on a OSE's dataset, which is on dementia patients, and we discovered that these are very interesting findings, we discovered that when education level is low, say in this case less than equal to 8, we can see that the number of demented patients is very high compared to number of non-demented patients, at least in this dataset. But for the same dataset, when education level is high, big, so the patients had long years of education, then among those patients, the number of non-demented patients is a lot higher than the number of demented patients. So education has influence on dementia, it looks like, at least from this data set. So this is interesting. And similarly, we can also see SES, socioeconomic standard or background, also has influence on dementia, at least according to this data set. And here we can see for similar brain condition with better socioeconomic standard, generally people have less percentage of dementia. So this sort of thing can be actually discovered, and this knowledge discovery is an ongoing process. And many people say it's data science or data arts, because you need to be creative, you need to do those kind of queries, those kind of analysis. Decision trees and forests can help you to build it, but then you need to continue exploration to find more knowledge, dig out more information and knowledge from your dataset. We then presented another paper on knowledge discovery, and we actually in this paper presented a full framework for knowledge discovery, and we identified a new definition of interesting rules, and this framework you can apply to discover more interesting rules and knowledge. So feel free to read this paper, and you can find these papers from my webpage. As usual, you can search me on Google and you will find my page. Go to the publication page and just search for the paper. So here is the Forex++ paper, and you can also search my other papers. Thanks for watching. Okay, so that's the end of the video. Now I can promise you this was the last video. No more video. Now you can see me live. And
No, that was very interesting. And we got a really fantastic couple of questions during it.
Okay.
Cameron asks about the difference between correlation and causation, and how you correct for that.
So that's a good question, Kevin. My understanding about that is correlation does not always mean causation. Correlation is simply if we have two attributes, two variables, are they changing similarly? If one decreases, does the other one also decrease? Or if one increases, does the other one also increase or decrease? But it's always the case. So their relationship is very defined. So one increases, other one either increases or decreases all the time. For example, age and height, right? So in high schools, for students in high schools, the age increases, the height also increases. So there is a strong positive correlation there. But among the entire population of Australia, the correlation between age and height may not be as strong. So that's correlation, but correlation always does not mean there is a causation. So causation is possibly one causes the other one happening. Okay, so the correlation can be happening just because of other things. There are many other things. For example, I can think of I'm trying to think of a good example. Say the city size and the number of cars in a city, possibly they are correlated. The city size increases, the number of cars also increases, but it is not, the number of car is not caused by the size of the city, it's caused by the population in the city. So when the city size is big, that means generally the population of that city is also big, and that is causing the number of cars increasing in the city. But when you look at correlation between city size and number of cars in that city, it looks like they are strongly correlated, but one is not causing the other one. Does it answer the question?
Sure. It's a very good explanation of the difference. But with respect to that particular study and the relationship between, for example, education and dementia, to what extent is that causation or correlation?
That's correlation. That is not a causation. Possibly, it's difficult to say whether it is a causation without strong evidence, but we can see that there is a relationship. There is something happening. So data mining generally explores this type of information, and as I showed you, then you can make some more queries to actually dig out more information, but then it is for the domain experts to actually think about this, like the doctors, clinicians, nurses in that example, or psychologists, social science people, to actually then think whether there is a causation or not, whether really studying more makes brain act differently to and more resilient to dementia or not, or more resistant to dementia or not. But simply just doing this data mining, we possibly can't conclude that. It requires further study. But with this data mining, with this knowledge, it can support that further study.
Fantastic, thank you. So Matt Venn, who said in the chat we'd better sign up to the full course so we can avoid dementia. Yeah, you might be in the clear, but probably still best to just sign up just in case. There's heaps of questions, so we might just keep going and then have a nice long extended one at the end.
Okay, thank you. Okay, so that was the last video, as I promised. Now, next few slides are actually explaining exactly what I showed you in the video, so I don't need to give the lecture now. You see, or at least for this part. So this was the Excel file and exploring few things and doing some Microsoft Access queries, SQL queries. This was the paper. Now, after that, we will talk about, so that was the video. Now it's a live one. So in this subject, we also teach you, or we also teach the students about the theoretical background, theoretical justification or theoretical knowledge on the various data mining techniques. It's not just we show tools and we just demonstrate that it can be done, but we also try to give the basic understanding why it can be done this way, what really happens in the backend. Because I have a feeling that you will possibly agree that when you know exactly how a tool or a technique works, then you will have better control on it, right? So you just don't know how to use it, but you know the inner mechanism of these tools and techniques, and that way you can actually apply it more sensibly in different situations. I can share with you some vague examples, because if I give the detailed example, it will take long, that there are many data miners or data analysts were using data mining techniques in a very incorrect way, in nonsensible way. So possibly, I don't know, it's just a human mistake, human error, but possibly a better understanding of why things happen according and how things happen, or what is the inner mechanism, could actually give better understanding. So this will be taught as well, but in this short course I will not go into deep details. For example, here I'm just showing a couple of slides on this. Here that was the toy example data set, and if you ask Weka or Orange or other software, data mining softwares, there are lots of data mining libraries in Python as well. Scikit-learn, NumPy, SciPy, these kind of Python libraries are very, very useful for you to write a small program to implement an algorithm or to use an algorithm. The advantage of Python coding is that there is a community contribution sort of thing. Many people are developing different algorithms. Libraries are freely available. You can use it, and it's also a very fluid language in a way. It's very flexible, and also the graphic part of that language is very useful. You can draw different graphs and plots, etc., very easily compared to. Look, I'm a big fan of Java, but when we first learned Java, it was very difficult with using breezy swing, etc., to draw something. Lots of lines of code just to draw a straight line. But Java has improved from that a lot. But Python is also very good. So there are many other software tools that you can use to build decision trees, forests, or do some clustering. Here is an example of a decision tree that you can just build within a blink of an eye if you're using a software. But how does it actually happen? So what really happens in the background? So that is also taught in this subject, in this course. For example, I mean, at a surface level, it actually, there is an algorithm behind it, and it is a systematic approach. It actually tests attribute one by one. So for example, here we have two attributes, qualification and salary, and the third attribute is of course your class attribute, which is position. In this case, class attribute, remember, that's the target attribute. For example, in the previous diabetes dataset, it was the diabetes test result, tested positive or tested negative. And you can actually choose any attribute as a class attribute. So here is again one example of your requirement of understanding of data analysis, so you know which attribute to choose. And that requirement of understanding is important from day one, when you start collecting data, when you design your survey questions, and when you know which type of data you want to collect, because you want to get that sort of analysis done. Or if the data sets or databases are already there, how to build a data set, how to combine them, what sort of information you need, etc. And I can give a long list of examples on that, but to be brief, okay, so how it builds, how the decision tree works, it tests the attributes one by one. First, it tests the attribute qualification. Here in this case, it checks what are the possible values, MS and PhD. There are two possible values here. And then it tries to understand its suitability, the suitability of this attribute qualification in classifying the class attribute, in differentiating, in distinguishing the values of the class attribute, how clearly this attribute qualification can classify, can divide the class attribute into two homogeneous groups. One group will be positive only. No, one group is senior only in this example, another group will be junior only. So can it do it, and how accurately it can do it? So it will analyze that for this attribute, and then it will also analyze that for all other attributes, in this case salary, and it will also do the similar analysis for this attribute. How does it assess the suitability or accuracy of classification of an attribute? There are many different ways. There are many different metrics, I should rather say. For example, information gain ratio, Gini index, etc. So there are various techniques to assess the suitabilities, and different algorithms will use different. And in this subject, we will also explain in details like exactly how it works. So to the level that you can actually, without using Weka or any other software tool, you can actually build a decision tree and forest by yourself. And similarly, you can do missing value imputation, you can do classification, clustering, etc. So that is one slide. And the other slide, and I will not go into the details of how it actually works because of the limitation of time. And the next slide, and we are almost towards the end, next slide is about decision forest. You possibly already know what decision forest is. All I was trying to display here is that from the same data set, you can have a tree that says if qualification equals MS, then the position is junior, and if qualification equals PhD, then the position is senior. And if you look at this data set now, you will see that that's 100% true. So whenever the qualification is MS, the position is junior. Actually, there are 6 such records where qualification is MS and position is junior, and 9 records where qualification is PhD and position is senior. So that's a very acceptable or confident set of rules. But at the same time, from the same data set, you can actually see some other type of pattern also exists. For example, if salary is less than 86, then the position is junior. If salary is greater than 86, anything more than 86, then the position is senior. And that's also equally true for this data set. So from a data set, you can actually explore multiple patterns. Okay, so one set of patterns may be one decision tree. One decision tree may present one set of patterns, but if you build multiple decision trees, then you can see multiple sets of patterns, right? And there are many work on this. There are many different research works there on this. And also there are research on or techniques on how to optimize the number of trees. So how many trees are, so we want less number of tree but maximum knowledge. So how do you do that? Something like that. So that those kind of things are also discussed in this subject. Now I will just take 2 or 3 more minutes just to introduce clustering, because last week also I wanted to talk about clustering. I could not. Just to let you know, for in case if you do not know, I know many of you already know what clustering is. So clustering is like, imagine this is a data set, age and height in this case. So if imagine that this data set has only 2 attributes. Okay, I carefully chose 2 attributes so that I can plot them. Now, if you plot these values, so for example, on the x-axis, you consider the age values, and on the y-axis, you consider the height values. Then if you plot each record as a dot, for example, age 23 and height 6.5. So that's the first record is this dot. Then you can get a number of dots, right? And you can clearly see possibly from this graph that there are 4 different groups of people. So these four people are kind of similar to each other. These 4 people are similar. These 4 people and these 4 people are similar. So there are different groups. So that's clustering. If you have a data set, and now this was a simple data set, 2-dimensional, only few records, so it's doable. But when your dimension is high, say you have 50, 60 different variables, and you have thousands and millions of records, then how do you automatically find out clustering? So clusters of groups of people, and that's another way of discovering knowledge. And here is an example. You can actually, if I have time, I can demonstrate this on real life in terms of I can share my screen and I can show it. But here is an example. You can choose a clustering technique on Weka and you can cluster the records, something like this. And that's it for today's lecture. But before I finish the lecture, I will ask Guy. Guy, do we have a couple of minutes, few minutes to demonstrate clustering?
Sure, we'll go for that, and then I'll pick a few questions out.
Okay, so basically, I will be very brief. I think I have already. You are now seeing my screen. It's not a video anymore, so you can see this is the Weka Explorer, and I have opened this file called diabetes file that you have. One thing I wanted to also tell you that when you have this Weka Explorer and you open a file, in this case diabetes.arff file, you can actually look at these attributes to also see various information, learn various information. For example, class, you can see tested negative 500 and tested positive 268. So you can see that the blue is negative and red is positive, and there are 500 patients with negative test result and 268 patients with positive test result. And then you can choose another attribute, say for example age, and you can learn various information about that attribute. So minimum value was 21, maximum was 81 in this data set. More interestingly, you can see when age is small, low, like 21, then you have more tested negative records. Remember, blue is tested negative, than tested positives. So it shows that diabetics chance at a lower age, at an early age, is low. Chance of being a patient, chance of a patient being diabetic is low. But when age increases, then here you can see gradually the proportion of red is increasing as well, something like that. So just this is one thing. And as an example of clustering, so if you choose from there, previously we used to choose classify to build trees, etc. in my previous examples. You can also choose cluster, and then you can choose some clustering algorithms. One of our algorithm Gen Class Plus is implemented in Weka, and you can download that. How you can do that? Please watch my YouTube videos, and in those YouTube videos on my YouTube channel, Zahid's Data Mining channel, I have demonstrated how exactly you can install. Simple, but it will take 2 minutes, 3 minutes to me explain, but I don't have I don't think we have the time. I'm rushing, and you are also rushing, I know. So that's the algorithm. If I choose that algorithm cluster, and then if I choose that one, and then if I choose cluster, start cluster, then here is a clustering result. So it shows the clustering results. I can see that there are 2 groups, so it automatically divides these diabetes patients into 2 different groups, and it is saying that for one group the average values are like this. For preg value is 4. For the other group, the preg value will be 2, and plus value is 140, plus value is 170 for the other group. So this is how it tells us how the 2 groups are divided. On an average, one group has this, on an average, the other group has that. You can actually see that try to see the visualization as well. You can visualize these things, distribution of the records, etc. You can choose on one hand, as an x-axis maybe age, and as y-axis maybe something else, maybe mass. You can see how records are divided in different groups, etc. So that cluster visualization is a slightly, like for exploratory purpose. And also you can, generally you may ask why people need to do clustering. Sometime, and a quick answer to that will be, sometime you have a data set that does not have any labels. Okay, for example, I can give you the records of everybody, or records of the residents of a city, say Bathurst, and I can just give various information, their ages, their number of dependents, or their household income, or etc. And then what do you do with this? That data set? There is no class attribute as such, so sometimes the records are unlabeled. So in situation like that, generally people use clustering to first group the records into different groups, and then study each group carefully. What sort of group is this? And then they find, possibly, I'm just giving an example, wow, this group is heavily say religious group. Okay, so this is a religious group, and this is a possibly less religious, non-religious group. So, or they can find maybe this is a very sporting group. They go for sports, various types of physical activities, etc. And this is kind of a little bit of relaxed group. And then they can label those records according to those different understanding of groups, and then they can build a classifier, a decision tree, to see the patterns of being what is the pattern, or what are the patterns of lazy people. I mean, look, I don't know if my examples are being silly, but let's say, okay, let's go with this lazy group of people and very sporting group of people, right? And we can then learn their characteristics and etc. So clustering, maybe in that sense, is the first step. If you have a data set without any labels, you can do clustering. And with that, maybe I can stop my lecture almost today, and because that was the last slide. Yes, that was the last slide.
Beauty. Thanks, Zahid. We'll just go for a few questions. Hamilton's asked, where can I get the ARF test files mentioned in week 1 and 2? I'm not 100% certain what that is talking about. AARF test files. Does that make any sense to you?
I think the question is where to get the test files, the .arff files. So when you install Weka, then it comes with that installation as well. So when you download Weka, it's free download. If you can Google search Weka and download, and then if you store it, save it in your hard disk, then go to that folder. You will see there is a folder called data, and within that data folder, you will have these .arff files as a start play with.
Beauty. Okay, thank you. On Weka, there's been a few questions about whether it'll be used a lot in this subject. And also, Robin's been talking about different tools that can be used. Is there any particular reason why you would use one tool over the other?
Not really. I mean, any of the tools can actually do the same thing. At the end of the day, the algorithms are the same algorithms that are being used differently through different tools. No, I mean the reason for choosing Weka was it's very common among the academic world, so they generally use it because there are already lots of algorithms implemented there. But in this subject, we also briefly demonstrate how to use Python to actually do similar things in Python, but that requires some sort of programming understanding and programming knowledge. If one does not know what object-oriented programming is and how to do programming in Python, he may find it a little bit difficult. So that's why, for the demonstration purpose and to our main goal here is to convey the message how data mining works, what are the things that happen in the background in the as a technique, and also we teach those things. Look, one advantage is the subject. Look, this is only one subject in the course. There are many other subjects, so you can actually choose various subjects. These are optional subjects. So the way we design the subject is basically we are teaching how to do various components of the data mining lifecycle, and we are demonstrating that through the algorithms that we developed here at CSU. For example, for missing value imputation, we demonstrate DMI or CME. We had around 10 or 12 missing value imputation techniques that we proposed, but we are teaching one or two, and then we compare that with some other existing techniques. So the advantage is you can hear about a technique, how it works, why it does it that way, why not the other ways, from the mouth of the authors, from the authors themselves. So the people who actually develop the technique are teaching you those techniques. So that's why we chose those techniques, and we implemented these techniques in Weka so that we can use it for teaching purpose as well. That is one reason we are using Weka to demonstrate, but you can use any other similar tools.
Okay, and final question for the night comes from David. He's talking about the tree where you have the junior and senior according to salary.
Mm-hmm.
He was sort of noting that there's a gap between 86 and 143 in salary.
Yeah.
And wondering whether there needs to be an additional branch or whether that is just a function of its classification.
Okay, good question, David. Look, David, this is a toy data set, and in this data set, possibly I deliberately wanted to have two distinct groups. There is a clear gap. Even if the data set records are more contiguous, more close to each other, the tree will actually try to find out the split point, the best split point where it can divide the records into two different groups. And the trees are also very simple because the data set was very simple. But if you go to my previous examples, you can see, like here, you can see this tree, it did not choose just one level to reach to the leaf. So here is the leaf, but for that it needed to check plus and mass both, right? So it can actually, and to reach to this leaf, it needed to check age plus mass, 3 attributes out of 9. So to reach to this leaf. So you are right that sometimes there will be more attributes needed, more splitting needed to reach to a as homogeneous leaf as possible. But because that example was very simple and the data set was a very simple data set, there is a big gap between these two, and the tree easily finds that within this gap, if I divide the records, one group of records is fully junior group, another is fully senior group.
Wonderful.
I hope I answered the question, David, but yeah.
No, it sounded good to me. But that doesn't mean much. It's got to be for these students who no doubt have more of an idea about statistics than I do. Okay, thank you so much, Sahid. Another very interesting and complex lecture. Thank you everyone for coming along and for sticking around a little bit late again. You know, I'm quite happy to keep going for 75 minutes if that's what it takes. Leif, thank you for hanging around, and yeah, look forward to catching up next week. So, hey, what are you're not going to be here for the next couple of weeks, are you?
Yes, Guy, I will be attending a conference in China from next week, so that's why I will be out of office, out of country. But my colleague, Dr. Michael Byung, will be here, and he will be giving. Actually, he is now in China. He is attending a conference, and he is coming back on Sunday maybe, and then he will be giving the remaining 2 lectures. The conference that I'm attending is on data mining. They call it ADMA, Advanced Data Mining Applications. And we have maybe 2 or 3 papers there to present. So that's the reason. It's a very good conference. Yeah.
Well, I hope you enjoy it. Thanks so much for the 2 lectures. It's been really interesting. Hope to hear more of what you've been up to. Keep us posted in the forums.
Thank you very much. It was a pleasure. And please watch my YouTube videos. So I will be updating things in YouTube videos. And please be in touch with me if you have any questions.